Hi, this is Mrs. Slater, and today we're going to divide and simplify radical expressions. And the general formula for doing so is looking at a division problem. So the index, as long as it's the same, we're going to be able to combine them all under one radical. So if I had something like the square root of 16 and the square root of 9, I'll be able to put all of that under one radical and then solve to get an answer without a radical sign, 4/3. Okay? I also can do the exact same idea just in reverse. So I can have them all under one radical, and then I can split it up so they both have the same index. And it just makes it easier for some type of problems to either put them all together one or separating them. And these examples will show you what I'm talking about. For this one, 4/9 is maybe not something that you can simplify. But if you separate it into two different radicals, we know the square root of 4 is 2 and the square root of 9 is 3. So that would be your final answer. On this way, the simplest way is to put them all together. Now, with a lot of practice, you'll end up finding out, okay, which ones you have to put together and which ones you don't, just by doing a little mental math. Because I know that the square root of 100 ends up being the answer to 200 divided by 2, and I know that that's a perfect square. On the next one, the 4th root of 16, may have to get your calculators out, so go ahead and push pause. For this one, splitting it up would be best because I know the 4th root of 16 is 2, and the 4th root of x to the 4th is x. It starts with an even index, so we've got to make sure we guarantee that that's going to be positive. So that's going to have an absolute value sign on it. The next one would be easier to put them together. So 81 divided by 3 is 27, and the value of cube root of 27 is 3. Final answer, 21. Okay? Another type is the 5th root of 32. Lots of things going on here, so just be organized. 5th root of 32, a to the 5th. We're going to solve that one. Then we're going to look at what's in the denominator. Okay, so individually, the 5th root of 32 is going to be 2. The 5th root of a to the 5th is just dividing those the exponent and their index to get a to the first power. 5th root of 243, again, use your calculator if you need to. You should have gotten 3 and b. Odd index, do not have to worry about absolute value signs, so that is going to be our final answer. Okay, and then on this one, if you are wanting to solve it individually, you can, but look ahead. Look at like 64 divided by 2. That's 32, which we know from the previous problem, that is a perfect 5th root. So putting them together is definitely going to be the easiest way to go here. I'm going to adjust a little bit because it looks like I have a denominator. A to the 5th is going to still remain in the bottom, and b to the 5th would remain on the top. So now we can look at them individually. 5th root of 32 is 2. 5th root of b to the 5th is b. 5th root of a to the 5th is a. And that's going to be your final answer. No absolute value needed because it's an odd index. All right, so when we're adding and subtracting them, there are certain things to remember. Any two real numbers can be added together. For example, 7 radical 3 can be expressed as 7 plus radical 3. No decimals. Do not use your calculator for that. We cannot simplify this sum. However, we can't simplify that anymore. However, when we have like radicals, we can simplify, and that's what I want to show you some examples of here. So you see radical 3, pretend like they are x's. What would you normally do when they're just x's? You would put 9x, right? Well, let's look at the same idea here. If they have the same radical, then your answer is going to be 9 radical 3. Use that as a common factor. Again, same, all same. So we're going to look at the coefficient and put all those together. 2 plus 3 is 5. 5 minus 7 is negative 2. So the answer is negative 2 cube root of 7. Okay, so now let's add radicals when the radicals are not the same. So like this is me right here. It says it looks tough, but I can do it, meaning you can do it. First step we're going to do is simplify the square root of 12. Again, what I mean by simplifying, we're going to take that and split it up into what's a perfect square and what's not a perfect square. I know 4 goes into that 3 times, still remaining with this 2 radical 3. And then I'm going to clean up this next one with the next step. We're going to evaluate radical 4 because that is a perfect square. It'd be 2 times that 5 from the beginning, square root of 3 plus 2 radical 3. The third step here is going to be to multiply the 5 times 2. So we're on our way to simplifying, and notice we have like radicals now. So we'll be able to put those together just as we did in the previous 2 problems. So like radicals, so 10 plus 2 is what we're going to add. 10 plus 2 for an answer of 12 radical 3. Here's some more with radicals that are not the same. So if we're going to split this into a perfect cube and what's not a perfect cube, there is nothing besides 1. So there's nothing to break down. Okay, so I'm going to erase that and go ahead and just write 7 cube root of 6. 35, let's see if there's a perfect cube. Okay, and mentally, let's just think of the perfect cubes. We've got 1 cubed, 2 cubed, 3 cubed, 4 cubed, and so on. None of these are going to be factors of 35. So if you have done all the math and now you notice that you're going to get 5 cubed, 35, neither one of them break down, then you're just going to have to stop. There's nothing else you can do about that. The next 2, I want you to go ahead and push pause and solve them both, and then we'll check your answers. Okay, so let's see how you did. If you look to the 8, you're going to have that broken down into square root of 4 and square root of 2. And then the second one has the square root of 2, so we know we can move on. Break this one down. That would be 7 times 2. And 7 times 2 is 14. And now you have like radicals, so your final answer is 20 square root of 2. And let's see how you do the next one. This breaks down into 4 and 3. The next one breaks down into 9 and 3. Like radicals means we can continue on. 3 times 2, negative 2 times 3, multiply, multiply, and they cancel each other out to get 0 for an answer. Okay, so I'll see you in class tomorrow.